Hi, I'm Gary Rubinstein. I'm a math teacher at Stuyvesant High School in New York City. I'm going to do the entire AP Precalculus practice exam number 1 from the College Board, starting with Section 1, multiple choice. The first part is no calculator. Now, they would give you 40 questions on the multiple choice, and they would give you 2 hours for that. But I'm going to go through these pretty quickly, but of course you can rewind and do all that. Let's just get right into it. Question 1, polynomial function is given. Where is it greater than 0? So the idea is that some numbers that you put in for p, like for instance p of 1, would equal -1 times -3 times 3, which would equal to +9. But not all numbers make it positive. So there is kind of a trick to doing questions like this. It is to make something called a sign chart. And what a sign chart is, like a number line. And on this number line, we first find when is p of x equal to 0. So for instance, if you put -2 into x plus 2, it would become 0. If you put +4 into the x minus 4, that would become 0. These other things wouldn't be 0 then, but the product of the 3 would be. And if you put 0 in for the -x, that would also make 0. So there's 3 numbers that equal 0. Now, it's not asking when does it equal 0. It's asking when is it greater than, well, it is asking when is it equal to 0, but also when is it greater than 0. So there's a couple of ways to do this. The easiest way, in my opinion, is to just say, okay, if I were to put something bigger than 5 into this function, we'd have negative, this x would be positive, x minus 4 would also be positive, x plus 2 would also be positive. So the x plus minus 4, and the x plus 2 are all positive, but there's a negative outside. So that would be negative. Now, unless you see some kind of like exponents up here, in a question like this, it generally alternates like that, whether it's plus or minus. The reason why is for bigger than 4, these 3 things are all positive, and there's a negative in front, which made it negative. But when you pick something in between 0 and 4, then when you pick something in between 0 and 4, x is positive, x minus 4 becomes negative, and x plus 2 is still positive. And when you multiply those all together, you get negative. With this negative outside, it becomes positive. Or if you like, nothing wrong with picking a number. For instance, remember p of 1 was +9. What's true for one number in an interval is true for every number in that interval. So now, finally, you would do this thing, by the way, regardless of what this said. But now to interpret the answer, they want to know when is it greater than or equal to 0. They're asking where are the pluses, but also the zeros. So you would describe this region as from -2 to infinity, negative infinity, together with everything from 0 to 4. They call that interval notation. And that's why number 1, the answer is D. Well, that's one question down, 39 to go. Number 2, now this is all no calculator. The function f is given by f of x equals 9 times 25 to the x power, which is equivalent. So notice how all the answer choices, because it is good to look at the answer choices for a multiple choice test, they all have a 5 here. So it seems like we probably want to take this 25 and rewrite it as 5 squared. Now, there's a rule of exponents that when you raise 5 to the second to the x power, you multiply the exponents together. And that's why I think, and by the way, I could make errors in this. I don't have an answer key. But I promise that most of the answers will be right. This one, I think the answer is D. Number 3. The figure shows a graph of a function. The 0 and extreme are labeled. So this is a 0, like an x-intercept. And turning point. This thing's called an inflection point. I don't know if that's important for this. The point of inflection. Point of inflection is basically when something switches from being a frowning graph to a smiling graph, otherwise known as concave down and concave up. So what do they want to know? In which interval is f increasing and the graph of f concave down? So here's increasing. From left to right, it's sort of going, here's some color for you. Left and right, it's going up. Here's another place where it's increasing. So the red is where it's increasing as I go from left to right. Like if it was a roller coaster, you're going up. And then from here, I'll make it green. That's decreasing. So we can see increasing, the red part, and decreasing is the green part. So it is, they want to know when is it increasing and concave down. Concave down basically means frowning. So that's why this part is increasing and it's a portion of a frown. But this part here is not, even though it's increasing, it's not concave down because it looks like a smile. And that's why it's from A to B, and it's choice A. Number 4. The function is, here's a function, a 6-degree function. So when they talk about end behavior, some graphs, like if it was f of x equals x squared, it would look like a smile. The ends would be going up in both directions. Whereas f of x equals negative x squared, the ends would be going down in both sides. The middle doesn't matter for this. On the other hand, if I had like x cubed, it looks more like that. It's going down to the left and up to the right. And f of x equals negative x to the third would be like that. Well, this describes the 4 different end behaviors. If the exponent is even of the highest power and the coefficient is positive, it's going to have the same end behavior as this. Exponent's even, coefficient's positive. So it's kind of look like this. But how do you describe that with this limit notation? Well, this up to the right basically means the limit as x gets really big, the function also gets really big. Whereas on this side, it's saying that as x gets to negative infinity to the left, the function itself gets really high up. So they're both infinity. That's why of the 4 choices, I believe the answer is B. Number 5, let x and y be positive constants. Which of the following is equivalent? So there are a couple of log rules for combining logs, manipulating them. Those 3 log rules are log of, I'll just say x times y can be written as log x plus log y. The second log rule is log of a quotient can be rewritten as the difference of the log of the numerator and the log of the denominator. And the third rule is if you have, let's just say, x to the c power, you can write it as c log. So these rules also work in reverse. So when I say 2 ln x minus 3 ln y, I'm going to use this rule number 3 in reverse. Ln means log base e. But basically, rule number 3 in reverse says if you see a c, something like a coefficient, you are permitted to kind of move it to be the exponent. And that's why this turns to ln x squared minus ln y to the third. Now I'm going to use rule number 2 in reverse that says if you have the difference of two logs, you can combine it into one log as a fraction. And that is why I think the answer is A. Number 6, the zeros. Zeros mean when does this thing equal 0? Whoops, what is that? Don't even know how I made that, because this is my first time using this very good program for screen recording. So if you can factor this thing, it's much easier to tell when it equals 0. For instance, I already know that -3 is one of the zeros, meaning if I put -3 in, x plus 3 would be 0, and even though this other thing wouldn't be 0, it wouldn't matter because we'd be multiplying by 0. I'm going to factor the x squared minus 2x minus 15 to x minus 5 times x plus 3. Those are two things that add to -2 and multiply to give me -15. So now I can see the other zeros. They don't even want to know what the zeros are. They just want to know how many are there. And it has exactly 3 distinct zeros, meaning neither of these numbers are repeats of each other. Graph of a rational function. So rational functions are equations, like f of x, that have like variables in the numerator and variables in the denominator also. Something like that, rational. And then they have pretty strange looking graphs often, where there's like asymptotes and strange things happen, like that and like that. That's rational functions. Can I erase everything? Erase all ink. There we go. So a vertical asymptote, that happens when the denominator equals 0. The thing gets undefined. So I'm looking for an x plus 5 in the denominator. Because if you put -5 in, it would become it would be 0 in the denominator. So, but the thing is, there's two answers. How could that be? Are there two answers to this question? No, because in B, when you look at the numerator, there's also an x plus 5, and those would they don't really. It means there's not an asymptote. It means that there's like some kind of hole there. So we cancel those out, and it would be a hole at -5. But D has x plus 5 in the denominator, no x plus 5 in the numerator, and that's the answer for question number 7. Number 8, here's a sinusoidal. It's like it's like a sine curve or some transformation of it. What's the period? Well, what period means is how long does it take to get from like the starting point to the next starting point. And as you can see, it went from 0 to 4, which means the answer is 4. Number 9. Here is semicircle and 4 line segments. So this is a function. This here is a graph of it. It's a real unusual function, f of x. Now, when you, just to give you a sense of this, we would say that, -1, 2, f of -3 is equal to 2, because there's like a dot here, and f of -2 is also equal to 2, because there's a dot here, and f of -1 is equal to 0, because there's a dot here, and f of 0 is equal to 1. That's the function. Now, when you do stuff to the function, and then you graph the new function, the transform function, it looks like the original, just kind of moved around. Sometimes it's distorted in some way. So here's how that works. If there's an x plus 1 in parentheses, it actually shifts to the left by 1, which is confusing. Some people might think right, but if it's in the parentheses, it's sort of opposite of what you might think, unless you think it's going to move left, then you'd be right. And this minus 2 means it shifts down by 2. If it was positive, it would shift up by 2. So what I would do is just take really any of these points, maybe the bottom of the semicircle, and if I moved it left 1 and down 2, it would end up here. And as you can see, that looks like this one. That's why the answer is choice A. So number 10. The exponential function is defined a times b to the x, where a and b are positive constants. The table gives which of the following is true. So an exponential function, I can see that when it's 0, it's 3/4, and then it becomes 3/2 and 3 and 6. You can see it's doubling each time. It's easy to see 3 times 2 is 6, maybe less easy to see. So what this means is that 3/4 is my a value. Oops, ignore that. And 2 is my b value. Because that way, when you put 0 in for x, so f of 0 is 3/4 times 2 to the 0, which is 2 to the 0 is 1, so it's just 3/4. But f of 1 is 3/4 times 2 to the 1, which is 3/2. So it agrees with that. Okay, maybe we don't need all that, but let's see. F demonstrates, if I were to make a graph of this, it would look like this: 3/4, which is about 0.75. Then we go to 3/2, which is double that, and then 3, and then 6. And they don't show, it says a and b are positive constants. So we don't have to worry about going what happens over here, although if you're wondering, that's usually what happens there. So does f demonstrate exponential decay? No, because it's going up. Exponential decay is when it looks like that. So it's not exponential decay, it's growth. But is it growth because a is greater than 0? No. A is not greater than 0. A is 3/4. It's growth because the b value is greater than 1. It has nothing to do with a being greater than 0. It's just what b is. If b is greater than 1, you get exponential growth. This one is choice D. I've done 1 through 10. I think I'm going to take a little break and then come back. So there are 28 of the part 1s have no calculator. I'm going to do this, I realize, in 3 videos. One for part 1, no calculator, one for part 1 with calculator, and then one for the part 2s. So we're going to get through the 28 part 1s with no calculator. We're a little more than a third of the way through those. Here's a function f and g. And f of g of x, well, that just means, I like to think of this as if it was a number. F of g of 2, for instance. How'd that get so thick? Let's see. I don't know. I don't know how to make the pen thinner. So f of g of 2 would be g of, that's weird, g equals, usually they say g of x equals. Anyway, g of 2 is 2 minus 3 over 2, which is negative 1/2. So f of g of 2 is the same thing as f g of 2 we established as negative 1/2, and then you would plug negative 1/2 into the f function. That's the idea. Now, they don't have numbers here, f of g of x. So what you do, f of g of x, you take f of x is square what's in the parentheses and then add 1. So is g of x squared plus 1. But g of x itself is its own kind of annoying thing. g of x is x minus 3 over x. Maybe if I zoom out, will I get... Maybe it was zoomed in. Squared plus 1 still looks too thick. So this is the answer, except we have to FOIL out, as they say, the numerator. X squared minus 6x plus 9 over x squared plus 1. X squared minus 6x. So I think the answer is choice C. Okay, number 12. The table shows values for a function. Okay, so there's x and there's g of x. Which of the following claim an explanation? So I just look at it first. So it goes from 53 and then up to 78 and 97. It's going up and up. They want to know, is it linear? Well, linear is if it goes up by... These are obviously 0 to 1, 1 to 2, 2 to 3, 3 to 4. I actually made this too thin, I think. If something's linear, every time it goes up by 1 or by whatever amount, the y value would go up by the same amount also. That's what would cause it to become a line. So 53 that goes up by 25. But 78 to 97 is not 25, it's only 19. And 97 to 110 is 13. And 110 to 117 is just 7. So it's not linear. I can cross off A and B. So it must be C or D. It must be quadratic. Well, how do you tell something quadratic? Sneaky thing you do. Remember how these changed by 25, 19, 13, and 7? If you see how the changes change, 6, 6, 6, ooh. Number of the devil. If that happens, though, if these numbers are the same, it's quadratic. So it's quadratic because the range of change over consecutive, see, that's not true. It's quadratic because the change in the average rates of change over the consecutive, that's what they're saying. The rates of change are 25, 9, and then the change of the average rates of change are all 6. Pretty confusing, but it is D. It's definitely not linear. You might have gotten it down to C or D. Number 13. And these are the first time I've ever looked at these questions, so that's why I have to read through. Here's a function. It's a sine function. And they want to know what's equivalent to it. So there's some formulas that it would be nice if they gave them to you, but they don't. And one of them is that there's a trig identity of sine A plus B, which is sine A cosine B. Maybe they ask sometimes. So sine A minus B is the same formula, except there's a minus here. And there's other ones. I'm not doing them all right now. But you could research cosine A plus B and cosine A minus B. Maybe there's also ones for tangent. Now, if I take this one and I change, if I say sine 2x, which is the same thing as sine x plus x, it becomes, using this, it becomes sine x cosine x plus cosine x sine x. But those are actually the same thing. So it's 2 sine x cosine x. So you can replace the 7. So if you just replace the sine 2x with 2 sine x cosine x, 7 times 2 is 14, and you end up with choice A. Number 14. So here they're talking about a function that has this special property. When the input values double, the output increases by 1. So, for instance, when this is 1, that's 2. But when the input doubles from 1 to 2, the output actually does not increase by 1. It increases by 2, so that one's out. This one over here, when we go from input of 1 to input of 2, the output went from 0 to 1. when I go from input 2 to input 4, the output went from 1 to 2. So this is the answer. The other ones don't have that property, like these linear ones. When the input goes up by, when the input doubles, the output actually doubles. It doesn't go up by 1. That's true for this one also. When the input doubles, the output actually doubles, which is not the same thing as going up by 1. It might go up by 1 sometimes, but this always goes up by 1 anytime the, so when I go from 4 to 8 for the input, the output goes from 2 to 3, choice B. Well, we are halfway through this video number 1 out of 3. Ooh, this one. Complex number is represented by a point in the complex plane. Whew. Real, imaginary. Complex plane, the point 3 plus 3i. Why is that so thick? Thickness 1. I'll make it thickness 0.5, see what happens. Too thin. Can't get thickness 0.75, apparently. So that's a point on the complex plane. It's kind of like the point 3, 3, but it's not an xy axis. It's a real imaginary plane. Numbers like here, this is just 3, and this is 3i. Points on the real axis versus the imaginary axis. But 3 plus 3i is here in this first quadrant. How do you express it with polar coordinates? So, okay. This one's pretty hard to explain without doing like an hour-long video, but I'm going to do my best. So, every number, complex number, can also be written in the form r cosine theta plus r I sine theta. So the r and theta are the length from 0, 0 to that point, and the theta is the angle. So in this case, sorry for my voice breaking, this angle is obviously 45 degrees because it's like a square, which in radians is pi over 4 radians. Pi is like 180 degrees, so pi over 4 radians is 45 degrees. And this length here, if I did the Pythagorean theorem, well, it's a 45, 45, 90 right triangle, so it's 3, 3, 3 root 2. Or if you like, r squared is 3 squared plus 3 squared, which is square root of 8, which is 18. So r is the square root of 18, which is square root of 2 times 9, which is 3 root 2. So this 3 plus 3i can be written as 3 root 2 cosine pi over 4 plus 3 root 2i sine pi over 4, which you could move the pi out a little bit, and either way you get choice C. Well, did the best I could to do that one in a short period of time. The figure below, the figure shows a circle centered at the origin with an angle of theta radians in standard position. Terminal ray intersects the circle at point P. And point R is also on the circle. The coordinates of P are x, y. The coordinates of R are x, negative y. Which of the following is true? So they want to know about sine theta. Basically, what does it equal? So it's not a unit circle. It's got 5, 0 on it. Well, if this circle was a unit circle, if it was, then the sine would be the y coordinate of that point. So if this was xy, the sine would be the y coordinate, because the x is the cosine and the y is the sine. If this was 1. But if you make this circle bigger, it sort of turns this whole thing gets bigger. So if this was xy, if this is 5 times bigger, so if this is xy, this would be 5x, 5y. But if this is xy, like it is, on the smaller circle, it would be x over 5 comma y over 5. Now x is negative, and that's okay, because sine of an angle between 0 and 180 is negative. So the answer to this question is actually sine of the angle is the point on the unit circle. On the unit circle that would, where this angle would intersect it. So it's actually, sine is actually y over 5. That's a very hard question. It's D. I could see somebody saying I could imagine somebody saying C, because they're saying, well, isn't sine negative? Sorry, no. If it was, no, it's D. Yeah, because sine is positive in quadrant 2 also. So it is D, because the ratio of the vertical displacement. Yeah, it's y over 5. If it was cosine, I can imagine someone putting a negative there, but it's just y over 5. It's kind of like related. If this is 5, and this would be y, and this right triangle is kind of related to the sine, and the opposite would be y, and the hypotenuse would be 5, like SOHCAHTOA. However you do it, the answer is D. I didn't do the best job explaining that one, but that's all I'm going to do for this. Okay, let's look at 17. Here's a function, 3x squared plus 2x plus 1. The graph of which of the following functions is the image of the graph after a vertical dilation of the graph? So, f of x, the graph would be some kind of parabola. And they're saying, what if there was a dilation, vertical dilation, by a factor of 2? So if this thing kind of got stretched out, so that every point sort of got doubled, it would be like a sort of a skinnier parabola. The way you get vertical dilation, I'll call it g of x. You just multiply the entire function by 2. So when you distribute that through, you get 6x squared plus 4x plus 2, which is B. That's all. That's what causes a vertical dilation. We see it in like a sine graph sometimes. Sine x versus 2 sine x. And all that happens is you put a 2 in front of the whole thing. 18. Okay, so here's a table. F and G are defined for all real numbers, but we just have a couple of x values here. Let h be the function divided by h of x. So the question is, what's h of 0? Now, there's no h function, but h of 0 is f of g of 0. But g of 0 is 1. So we get f of 1, and f of 1 is negative 2. And that's why that's the answer for that one. This one has got a lot of words in it. The functions f and g are defined for all real numbers such that g of x equals f parentheses 2, f of 2 parentheses x minus 4. So there's been a bunch of questions about how graphs change when you do the transformations. So maybe I should summarize that a little bit. Oops. So if you have a function, y equals f of x, and it has some kind of graph, whatever it is, if you have 2f of x, sorry, let me do this in a nice order. F of x plus 2 would shift this thing up by 2. F of x plus 2 like that would shift it to the left by 2. And if this was minus, it would go down. And if this was minus, it would go right. Then there's also, if I have like 2f of x, that, like in the last question, does kind of dilation, stretches it upward. And if you have in the parentheses a 2x, that actually compresses it, horizontal compression. So, and then you could combine them. So when I see this, I see a horizontal compression because of the 2 and a shift of 4 to the right. So some people are tempted to distribute this to get 8, but you should not. It is 4 units, and it's 4 units to the right. This is actually the only one that has that. It has they all say horizontal dilation by a factor, well, some say 2, some say 4. Dilation by a factor of a half, because this 2 actually smushes it, so it's a dilation by a factor of a half. And then the horizontal translation of 4 units to the right, not to the left. And that's why that one is D. So here's a graph. And when I look at this graph, first of all, you can't tell whether it's sine or cosine just based on the graph, because a sine is just cosine is just a shifted sign. But for one thing we can see is that 1, 2, 3, 4, 5, 6. So the midline, regardless, is here at y equals minus 1. That's why they all have minus 1 here. So that doesn't actually help us that much. They also have amplitude of 3, which is why there's a 3 here. So none of those have helped us that much. So there's multiple ways to write something like this. If I want to think of it, if it is a sine, I would think of this as the starting point. Sorry. I would think of that as the starting point. So it would be a shift. This is pi over 2. It would be a shift of pi over 4. So it would be 3 sine bracket. I'll deal with that in a second. The shift would be to the right, so it would be x minus pi over 4. Now the number in here is going to be 2 pi over whatever the period is. And the period of this is pi. The easiest way to see that is if I go from a minimum to another minimum. See, that distance would be pi. So 2 pi over pi. That shade of green is not the best shade for instructional purposes. Anyway, those pi's cancel out. You get 2. And that's why the answer to this question is actually choice C. Some people, well, that's what the answer is. If they wanted to make the answer cosine, why don't I'm going to do a little bit more about this question, just because they could have, there's a answer that they could have made a cosine answer if they wanted to. That would look like this. If they really want to have a positive 3 cosine, we'd have to go like that. Cosine goes like that when it's positive. So another answer, which it wasn't a choice, but it would be 3 cosine bracket, still a 2 here because the period would still be pi, so 2 pi over pi is 2, parentheses, x, but now we're shifted to the right by pi over 2, so it would be minus pi over 2 plus 1. Now that's not one of the choices here, so it wasn't right, but that could have been a choice, and it would have been right had it been. Okay, 21. Rational function graphed in the xy plane, x1 and x equals 7, the polynomial and the numerator. Okay, so they have some kind of function with a numerator and a denominator. Consider, this is a strange thing to say, consider. What's to consider? I don't know. They're just saying consider x equals 1. The polynomial in the numerator of f has a 0 at x equals 1. So we have an x minus 1 here. And does not have a 0 at x equals 7. So there's some other stuff, but there's no x minus 7 here. The polynomial in the denominator has zeros at both x equals 1 and x equals 7. Now there's more stuff, but they're just not telling us. Ooh, the multiplicities of the zeros at x equal 1 in the numerator are equal. That means if there's like an exponent here, like a 3, there'd be a 3 here also. So here's what they're getting at. Normally when the denominator is 0, there is a vertical asymptote. And then they had a question about this, one of the first questions actually. Except when the numerator has the same thing and then they cancel out, then there's just a hole there. So that's why there's a vertical asymptote at x equals 7, but a hole at x equals 1. So that's why this is out. Vertical asymptote, no. Hole at 1, vertical asymptote. That's the answer. There was another one about asymptote versus hole earlier in the practice test. 22. The increasing function gives the number of followers of a new musical group on a social media site. The table gives the values. If a model is constructed, which is best applies. So it goes from 20 to 30, so it goes up by 10, but then 30 to 45 is not up by the same amount. So it's not linear. Now, 20 to 30, 30 over 20 is 3 halves, so it's times 3 halves. Now 45 over 30, if I reduce it, divide both sides by 5 first, let's say, 9 over 6, now divided by 3, is also 3 halves. So what this thing is a exponential, and it's this one, choice D. 23. Here's a 4th degree polynomial, and we don't know what A and B are. Then they say each of the zeros of k has multiplicity 1. So this thing factors, and when it factors, they'll all be exponent 1 here. There won't be any matching ones. Each of the zeros of k, in xy plane and x-intercept of the graph of k is 17.997, 0. So somewhere around 18, there's a dot on this graph. A 0, the function is called k. That's usually, they don't call functions k like that, but okay. There's also this imaginary complex number that makes this thing true. So here's something that you need to know about 4th degree equations. 4th degree equations, when there's a negative out here, usually look something like that. That's what a 4th degree equation usually looks like. Now, so it could have 4 real zeros. Now, they're telling us one of the zeros is complex, imaginary. Well, imaginary roots, you can't just have one. You can't have an odd number of them. So if there's 1, there's going to be 2, which means that this curve looks more like that. That's basically what we know. These numbers actually don't matter at all. They're just there to make you confused. The graph of k has 3 x-intercepts. No, it has only 2. Oh, maybe there's others. Has 4 real solutions? No. It has just 2. The graph is tangent to the x-axis. Tangent to the x-axis is where this happens, and that's not what's going on here. So just getting rid of those choices. Now it turns out that I said before, imaginary roots, it can't be just one of them. They always come in pairs, and those pairs are the same number except one's has a plus in the middle, and the other one has a minus in the middle, and that's why the answer is choice B. 24. Okay, we have logs, a lot of logs. What are all x-coordinates intersections? So when you have two functions and they intersect, when they intersect, that would mean that f of x and g of x for that x value would be equivalent to each other. So when they say find the points of intersection, they're asking us to find the x's so that f of x equals g of x. Now, that happens. We have to solve this equation. Log base 10 of x minus 1 plus log base 10 of x plus 3 equals log base 10 of x plus 9. Now remember earlier I mentioned there were log rules. Log plus log can be rewritten as the product, log of the product of the two things. Now, they're both log 10, so you can kind of cross out the log 10s, but be careful because those log 10s were there originally, and we just have to be careful about that. I'll show you what I mean. Now I can solve this equation, x squared plus 2x minus 3 equals x plus 9, x squared plus x minus 12 equals 0, factors to x plus 4, x minus 1. So it appears at first that there's two answers. Sorry, that's minus 3. It appears there's two answers. But you got to be careful because this equation, yes, this equation has two answers. But the original might not because log is only defined for positive numbers. So if you put 3 in, this becomes 2, which is positive. This becomes 6. This becomes 12. But if you put negative 4 in, these two things become negative, and log of a negative is undefined. And that is why the negative 4 has to be rejected, and it's just 3, and the answer is just A. So here's a trig equation. You got to be extra careful on these. Do not divide both sides by sine theta, as tempting as that is. That's like if you had x squared equals x and you divided both sides by x and you said x equals 1, you would lose that the x equals 0 is also an answer. The thing to do is actually subtract x from both sides, factor, and then get the two answers. So over here, the same thing. You add sine theta to both sides, you factor out the sine, you get 2 sine theta plus 1 equals 0. So you get sine theta equals 0, or sine theta equals negative 1/2. Now, sine theta equals 0, I personally like to think of a sine curve, and I see that between 0 and 2 pi, not including 2 pi, is just 0 and pi. Already, I'm down to choices A and B. Now, sine theta equals negative 1/2. That happens in two places, actually. The way I think of it is sine of 30 is 1/2. That's just a thing that you're supposed to know. So to get negative 1/2, here's 30 degrees on a unit circle. So negative 1/2 would be down here. Here's sine equaling 1/2. Here's sine equals negative 1/2. Now that 30 degrees is important because this is 30 also and this is 30, which makes, I better zoom in. So the answers are actually 180 plus 30, which is 210, and 360 minus 30, which is 330. So those are the answers, 210 and 330. In radians, 210 is 7 times 30, and 30 is pi over 6, so 7 pi over 6. And 330 is 11 times 30, or 11 pi over 6. And that's why the answer is choice B. 26. Now you should know you don't need to get every question right on this test to get a 5. So looking at this one, if you don't know it, you can get a few wrong. You can guess on a few, but I'm going to teach it anyway. So here's a graph of a polar function. So what that means is you plug in 0 into this function, and you get cosine 0, which is 1, so you get 4. You plug in 90, cosine of 2 times 90, cosine of 180 is negative 1, times 4 is negative 4. And basically you graph those points, 0, 4, 90, negative 4. So this was the first point that got plotted, and then that one. If you plug 180 in, 2 times 180 is 360, so 4 cosine of 360 is 1. I like to go like that. So cosine of 360 is 1. So 4 cosine 360 is 4 again, so 184. So that's the third point that gets plotted. 270 in for theta. 2 times 270 is 540. 540 is the same thing as 180. And 180, cosine of 180 is negative 1. 4 times, so negative 1. Times 4 is negative 4. So 270 is like facing this way, but it's negative. So the points get plotted this way, which means when you plot these points, it would look like this. It would start here, and it would go like that first, then like that, 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 then like that. I'm now numbering this sort of halves of these petals, and finally like that. I'm crossing out these numbers now because I'm now labeling the arcs. 1, let me use a different color. 1, 2, 3, 4, 5, 6, 7, 8. And what do they want to know? I know I use degrees. I think of this in degrees, but they want radians. Well, okay. If the domain is 0 to 90, which portion would you see? Well, you would see 0 was 4, and 90 was this negative 4. So, because 90 is facing up, but it's negative. So it would just be that. I'll make it a different color. That's the piece that we would see. And they want to know, what is that? That green thing? It's the portion... The portion of the given graph that remains consists of 2 pieces. One of those pieces is the portion from C to E. I need to erase a little bit to see what they're talking about. Yeah. So that's C. Can't see the E. Oh, there. That was to the middle. So they said, okay, we've told you about this piece. What else is there? It's that piece. So it's in quadrant 3 from C to D. From E, sorry, E's in the middle. From E to D. And this was choice D. So that was a pretty annoying question, for sure. They were basically asking, in what order were these petals drawn? 2 more questions in this video. Again, it's 3 videos. One for the part 1s that are that no calculator, one for the part 1s that are calculator, and one for the part 2s. You get an hour, basically. 2 hours for the part 1s, and then an hour for the part 2. So 3-hour test. So each of these videos maybe is an hour long, because I'm explaining it as I'm going along. 27. A physical therapy center has a bicycle that patients use for exercise. The height of the bicycle pedal above the ground periodically increases and decreases when used. The figure gives the position of the pedal at height of the figure gives the position of the pedal at a height of 12 inches above the ground at 0 the pedal's 8-inch arm defines a circular motion. They pedal 1 revolution per second. Which of the following could be an expression? So the way I see this question is that it starts off at 12. That's how high this thing is. And then 1 second later, it's back at 12. But in between, it goes up. So, and halfway between, it's also at 12 because it kind of ends up here. But the interesting thing is, quarter of the way between, it's up at this portion, which, because the diameter, the pedal's 8-inch arm. Yeah, so this pedal is this pedal is 8 inches. So it goes up at 1/4 of a second to 20. That's how high that is now, because it's 12 plus 8. And down here at 3/4, I noticed something about this arrow. This thing's going counterclockwise. Notice this arrow here. This arrow. So it actually starts here and it goes down first. So I should have put this, over here at 4, 12 minus 8. And then, so that's a quarter of the way through. And then halfway through, it's back to 12. And 3/4 of the way through, it's at its high point. So it looks like this. So what's this curve? Well, the middle line is 12. That's why there's a 12 here. And it's a sine curve, but it's going down first. So I look at this as -8 sine. Now, it's not quite this, plus 12, because there has to be, the period is 1. But then we need a b value here, and the rule is that b is always 2 pi over whatever the period is. The period is 1, because they tell us it, so there has to be a 2 pi there, and that's why the answer is choice D. And the last question for this video, question 28. This was harder to make. This video I sat down and did it in one shot, and tiring. 28. Consider the graph of the polar function. 1 plus 2. We did another question with polar before. That's where you have like the polar graph paper and you use r and theta instead of x and y. It's 1 plus 2 sine theta. And they want to know which is true about the distance between the points with polar, about the distance. Well, it's really useful to know what this thing looks like, I think. So what I like to do is do a theta r graph, almost like xy. What would that look like? 2 sine theta plus 1. So 1 would be in the middle. And 2 sine theta starts here. And at 2 pi gets back to there. But it goes from 1 in the middle. It goes up 2. Because of this 2 here. It goes up to 3. And this one goes down to -1. Now, when you translate these points to the polar, it goes like this. 1 at 0. At 90, it's all the way up at 3. Then at 180, it's back down to 1. So it goes like that. But then a funny thing happens here, because it actually hits 0. So it has to kind of do a little loop-de-loop here. That's called a cardioid with inner loop. Or, sorry, it's not called a cardioid. It's called a limosone with inner loop. It basically looks something like that. It goes back to the middle. That's what happened here. This little upside-down parabola causes a loop. I don't know. That's what it looks like. What do they want to know about it? The distance between the point and the origin. So the point and the origin has a distance, and then as theta changes, that distance changes also. So between 0 and pi over 2, from 0 degrees to 90 degrees. You see how it's getting bigger, 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 bigger? So it is increasing because f, yeah, I think the answer is choice A already. From 3 pi over 2, that's 270. This one's really confusing. I'm really thinking the answer is A. I know it's not decreasing from 0 to pi over 2, so it's not that. But this other interval's kind of weird between 270 and 11 pi over 6 is like 330. Oh, I see. I think from 270 to 330, which is somewhere over here. See what's happening if I zoom in on it? Whoop. It seems to me like the lines are getting shorter. No, they also look like they're getting a little longer. Oh, but 270 to 330 is actually this is 270. So 330 is somewhere over there. And yeah, the lines are getting shorter. It's inside the inner loop. That's really hard. Like it might feel like it's decreasing. Like, well, they have a choice for increasing and decreasing. What's actually happening there? It is actually decreasing. Like it's getting, but the thing is, it was negative. So I'm just going to go out on a limb and say the answer is choice A. Maybe it's wrong, but that's a hard question. I'm not going to stress out about it because you only need to get something, I don't know, 75 or an 80. I don't know exactly what it is to get a 5 on this. So I'm not going to stress. So that's the end of this, the first 28 questions. Hope you like this video. I don't know if I liked it, but I hope you did.